Nice background, by the way.
I figured it was thematically appropriate.
What's that system? It's identified?
RS off in outburst. But, you know, they probably all look the same to an artist's rendition, right? No real scientific knowledge we have at that scale.
No, but I mean, oftentimes when we talk with the artists, we try to specify certain things that we want to see in them based on the science. So yeah. I don't know. I don't know which part I just came in. I don't know which part you were commenting on specifically. So
it's a CV obviously going into a bright outburst from the surface. So, you know, it's a nova, but I mean, you wouldn't look at that and say like, oh yeah, I recognize RS Afiyuki from that.
Yeah, I just didn't know if maybe it was the convection on the donor or something like that was important. Anyway.
Greg, was everything fine in the high energy network session?
Well, 16 people said that they were interested in potentially showing up, so maybe we'll join, maybe we won't. The problem is that there's conflict. Like I imagine that of those 16, a fair number of them are also going to be interested in the CVs. And all the other ones, there's not conflict with as much as there is between, not conflict, but a time conflict between CV and high energy.
Yeah, same thing on our Friday sessions. Like I like to go to this, I like to go to that. A couple that I would go to today, but all at the same time.
Right. I mean,
people coming and going at times. Some people were there for 5 minutes and then leave and things like that. It's fine.
Oh yeah. Oh no, it's absolutely fine. I worry about the high energy network observing session just because it is trying to reboot, and if I have to go to one, I want to go to the CVs because of VY Aquarius being an outburst right now. But if it wasn't the case, I might go to the other ones to try to help them out. So anyway.
Yeah, sad story about VY Aquaria actually. It's been Florida where I'm at. It's usually this is our great time of the year. From rainy season finally ends in end of October or so, and then we have 5 or 6, even 7 days a week clear skies here, just an inch or two of rain each month, and it's been unusually cloudy and just a lot of upset in the tropics, I guess, for whatever reasons. Finally got a clear night the other night. I'm all primed, and I'm in a hurry. I'm rushing around, and I picked VZ Aquari and added it to my observing program, which was not an outburst, is a CV, but isn't doing anything at all exciting. So I got like 20 minutes of data on VZ Aquari that no one cares about because it's like, that's a quiescence. I wasted a clear night, maybe my only one.
You didn't waste it. It didn't go as planned.
Yeah, right. Yeah, well, it's 18th magnitude. So, the first several images I was shooting at, 30 seconds showed nothing, which was my clue. Like, is it faded? And even then I didn't figure it out. This is how confused I was, right?
It's perfectly standard these days, I think, to be this confused.
Yeah. But on the plus side, it was clear last night for about an hour. So I could get a bit of data on it before it both disappeared behind the trees and the clouds.
Excellent. Yeah, it's surprisingly, we haven't detected it in radio yet, which surprised the hell out of us. And I think I know why, but so we're probably going to do our densest monitoring of the source in the rapid decay, which is why it's super critical that AAVSO continue to monitor it before that, so we know when to trigger. But the lot of the simultaneous stuff evaporated when we didn't actually start detecting it like we thought we were going to. I just haven't had time to update the alert campaign because of all the talks I gave this weekend for this meeting. And technically I'm supposed to go on vacation today, but an ice cube neutrino source went off that I think I have to follow up now. So I have to write a proposal.
What target you are talking about?
VY Aquarii, Yosh. VY Aquarii.
VY Aquarii.
Victor. Oh, I forget what the yellow is. What the Y is.
the 10th magnitude one.
Oh
Yeah.
yeah. I mean,
Super
it's
outburst,
super
easy.
humping, yes.
So I didn't have anything planned for this session. If I don't know what sessions y'all got to attend or what session you got to attend maybe on Friday. I went to the spectroscopy session, and it was quite interesting. It's something I've been wanting to get into, along with every other kind of object that I'm interested in. There's never a lack of things to look at, but they had everybody go around and introduce each other, or introduce themselves rather. I don't know if y'all want to do that. I know a lot of you, at least through email and collaborative works. It seems to be the kind of the same group, right? That get together. We all met last year in New Mexico, which was great fun. It was very nice to get to finally meet a lot of y'all in person. Y'all are. I don't know if anybody. I think I know most of you. Steve Futcher.
We have a lot of shy people here. Show yourself.
Hi there.
Exciting. There you go. Greetings. Hi, Paula.
Okay.
So, again, didn't have anything planned out for today session. Thought we'd get together and talk a little bit. VOI query is a hot topic right now. Maybe if Greg wants to give us a little more chatting about that, what we're hoping to find from that, and why it's important to keep in observations. Keep it in our observing programs.
I will in a sec.
And some other things that we have been looking at observing. Types of targets. I've got a list of old novae or not so old novae from Dr. Fred Walder. Interested in he's very interested in novae and their evolution after outburst. So I try to get a observing program put together on that and out on the CV page. Will mention, I think probably all of you or most of you are already subscribed to the CV forum, but at the AVSO. But if you aren't, that you're guaranteed to get a flood of information from that. Patrick Schmier is co-leader of the CV section here, and he does a great job sending out information about objects in outburst. Usually my challenge is deciding, should I start observing that? Is that important? Or, why is that interesting? Which is why it's great having Greg here, talking about VOI query. And Dr. Waller Fred at the last AAVSO session talked about a couple of the very unusual old novae that he's studying, or not so old, still active novae, and what kind of science. Basically it's at the point on some of those, like, why is it even doing this? Why is it still bright? Like, oh, nobody knows. So you got to keep watching targets like that, right? And keeping an eye on old novae, because you're not sure exactly what they do. Also interesting to try to get orbital periods. Once they start fading, when they're in outburst, the signal's not there. But once the hot outburst pseudo atmosphere, if you will, dissipates, you can see down into the actual binary and be able to hopefully pick up a photometric signal for periods and give us more statistical data on what kind of physical parameters we're seeing in novae systems. So if one's got particular questions, again, Greg,
I can talk about VOI query as you asked.
Yeah.
So, as I asked questions about the radio sources from Paula's talk. That's because I do a lot of the work with Deanne Kopajans and various people on the radio follow-up of the non-magnetic CVs. And we've had a very interesting issue is that we've been observing them with a radio telescope in South Africa called Meerkat. And this is at a lower electromagnetic frequency than what we typically do. And we haven't been finding the nano detections as we were at, when we were looking at them at higher electromagnetic frequencies with a very large array. And so this is a little bit perplexing. One possibility could be that they're just much fainter at this frequency than others. So we were really excited when we saw VY Aquarius, which is a CV within about 100 parsecs going into a super outburst, because we thought that this would be a great source to really get some deep data on and finally get some good radio detections with Meerkat. We observed it twice in the past week or so. We haven't detected it yet, and so right now the plan is to actually look at it more in the rapid decay, because the one source that we know the most about for the radio emission for these non-magnetic CVs is SS-SIG. And in SS-SIG, we see a whole bunch of flares, and those flares seem to be most prevalent when the source is rapidly decaying in the optical. So the original campaign that I put out was basically focused on the idea of we were hoping to capture a bunch of these flares throughout the outburst, and we wanted to be able to do both monitoring of the whole outburst in general, because this actually is a relatively poorly studied source for some reason. Can't understand why, it being so close and going into super outbursts, but it hasn't been studied much in the modern era. And so the idea was to do lots of good photometry and lots of good spectroscopy on the optical side, add in X-rays and ultraviolet, which we have been doing. I actually need to talk to Christian Kniga to find out if he's extended his program past the 4 days of data we got. And then with the radio, the basic ideas for the rapid photometry is that spectroscopy is not just seeing different types of oscillations, but you actually can measure the radial velocity of emission lines and absorption lines in the source, and potentially get at the mass of this object. And since it's relatively bright, you're measuring the accretion disk right now in outburst, but it becomes in the realm of what people can actually do, amateurs, with their spectra, because it's so bright right now. Even potentially, with some of the higher resolution spectra, there might be some interesting things one could do, but probably not on the time resolved perspective. So that's the goals. Like I said, we're in a reevaluation period for the whole outburst, in terms of we're going to continue to do radio monitoring, but instead of doing it once a day, we're going to be doing it once every 3 days. And then when it comes time to the actual rapid decay, then we're going to be hitting it probably once or twice a day in the radio then. So what we need from AVSO is definitely we need continued simple monitoring of the source to know when it's actually going to go into that rapid decay. However, I think that even before the decay, there might be some interesting things that the CBA and et cetera, and that Patrick might be interested in doing. So I didn't want to change the campaign up too much. Unfortunately, I don't think Patrick's here. So, Paula, you have a hand up?
Yeah, so I was going to get some spectra this week. I have a night at APO, our 3.5 meter, but I just was informed that they're closing the observatories in New Mexico because of the governor's order for the vote. So I'm going to lose that night.
Yeah, that's unfortunate.
Yeah, I know. It's like my only chance
first.
to do something on it. But I was just wondering you know more about how many of these sources are detected after outbursts. I mean, SS-SIG is the one that's out there the most, but I'm just wondering if they're more of the long period types versus the short, and is there any, I mean, how many are now known during the outburst time?
So it's still only a handful for the dwarf nova outbursts.
Yeah,
and
is it like ZCAM? Do you remember the names? Are they all long period systems, or is it?
So I can't remember. I'd have to look at Deanne Kopajan's paper. So the paper is literally like dwarf novae are significant radio emitters.
Yeah, I know. I remember it too, but I can't remember the details.
Yeah, I'm on the paper. I just can't remember them. Right. Well, I'm on many papers, so I can't remember a lot of things.
Really understand. Yeah.
So I don't really know why some are radio bright and why some aren't. SS Sig seems to be exceptionally radio bright and really weird. And then there
Yeah,
are some.
it's weird in X-rays as well. I mean, it goes opposite to the usual, if I remember right. The way that the soft versus hard, and the way the X-rays behave.
But that I think is more because it's a white dwarf. I thought the X-rays, like I'm used to thinking about the X-rays from the X-ray binaries, and there you have the soft and hard states. But if I remember, because of the white dwarfs being a little bit farther out, I think you do actually get in the X-rays the sort of the flip of what we're used to seeing.
Yeah, but there's two sets of I'm just comparing to other dwarf novae and X-rays.
Oh, okay.
If I remember, it behaves different. I mean, the way that it goes up, or the time scale, there's something that was different about it than the others. So that's what I'm trying to think. If there's a link somehow between what the X-rays are doing and what the radio is doing, in the ones that form the I mean, I thought the original I thought they thought there was some kind of jet formation that produced synchrotron. Is that still the?
So SS Sig shows such rapid flares, and the timeliness of it in outbursts. And honestly, I have some other information that says that yes, it is a jetted source that I can't talk about.
Okay.
But it is so. I think it's definitely that's the case. The relativists suggest there. And then when we went to the fainter sources, and these were much fainter than SS Sig, it was indications were that they're likely to be synchrotron, but it's not a 100%, absolutely sure. The thing that what I am suspecting may be occurring is that the spectral index is what's called inverted, which means that as you get higher in radio frequency, the flux gets brighter, and you can get that in jet and synchrotron jet components. It just is a slightly different type of configuration of either the magnetic fields, the number densities, or the shape that leads to that type of spectra. And so, matter of fact, if SS Sig happens to go into outbursts in the next 24 hours, and if it's clear in Hawaii, we're actually doing some sub-millimeter observations of it, because I think it's going to be a bright sub-millimeter source. But so we don't know what's going on. SS Sig is weird. There are some other weird white dwarf radio emitters. I mentioned some of them in your talk. So AE Aquarii and AR SCO, they're differently weird. The weird thing is they're all about the same radio luminosity, but all three of them are probably differently radioluminous.
Uh-huh. No, it's a very interesting area, I think, to get into and find out what's going on. Right. Thanks.
Yep. No problem.
It's kind of odd, and anything about SS Sig being kind of obviously the namesake of that class of CVs, and yet and most well observed, and yet it's kind of odd. It sounds like I'm also puzzling over the jets in what is essentially is a very low magnetic field object, right? I mean,
shouldn't be a problem. It's the magnetic field and the accretion disk that probably matters,
which is being generated by the infalling matter.
Yeah. I mean,
it has a very high accretion rate. So that's what I think, maybe the trigger here, which is going to be the longer period systems. That's why I think, if you find, what is the period of VY Aquarii?
I want to say, is it not? I have it on the, sorry. I have it on.
Long? Does anybody
it's
know?
On the alert, I mentioned it.
I'm sure Josh knows off the top of his head here. He's muted though.
I
Or he
will
has in
be
VSX.
right now, so I am checking. Yes.
Okay.
I don't have a period.
There's no period. That's odd. Well, it could be, it could be the inclination, right? So it's harder to get it.
So there is some periodic behavior in it. I'm just trying to get to my discussion.
You look at the current data just taken in the last couple of days, both Josh and me, you can just look at the plot and see it.
Right.
Like 70, 60 minutes. I don't know.
So the white dwarf has a companion that's 90.8 5 minutes.
Okay.
Okay. So that's why I think it would be important to try to get, unless, well, a super outburst, you get more accretion onto the white dwarf. So
Right.
it could be that it happens in the short period once during a super outburst. But that would be the thing I think to see if, you know, because that's a SIG, we know it's a high accretion rate all the time, basically. So
Yeah,
the time goes in, yeah, that would be great.
We'd love to, but literally, so that we had this major program. This is part of the Thundercat program on Meerkat. It was the highest ranking part of Thundercat was the white dwarf stuff. So we had 250 hours over 5 years to spend on white dwarfs. And I've got to say that I've been I'm not the leader of it, but I'm a part of it. And I've been very disappointed with the number of detections we've got. And so it's indicative of an issue in our understanding. And so we have to wait for upgrades to Meerkat so that it'll go slightly higher in frequency, and or getting luckier with the VLA time allocation committee.
Okay.
Could you say something about Aquila X1?
Sure. I had a campaign about Aquila X1. I have been so, like, honestly, I've been sleeping 4 hours a night for the last 2 months, trying to juggle all this stuff. And so give me a second to remember where we were on Aquila X1, because did I set up a campaign on that as well?
I think so.
Yes.
Yeah, sorry guys. um, so, okay, yes. All right, now I remember what's going on with Aquila X1. So we have, what we were trying to do with Aquila X1 is we were trying to understand the relationship between how the ultraviolet and blue optical bands are related to the X-ray luminosity. And so we basically, I did a lot of work during the actual outburst where we were observing this to try to get things going. And we have the data in hand, but literally once that data got in hand, I got slammed by COVID-19 related administration duties. And so I haven't had a chance to follow it up. What we will be doing is, so we've got, like I said, we've got the SWIFT data, which has X-ray and UVOT, and we have multiple epochs of that. The person that did the analysis needs to redo the analysis with that, because I think there's always, she needs to be a little bit more careful about some of the issues with the nearby star. We also saw that some people as well showed some very rapid variability in this object. And Yosh, I think you were the one that pointed out that also may be related to not being careful enough with the with changes, for instance, maybe to the scene or something like that, affecting your extraction with that nearby star. So my plan is, after I go on vacation, which I go on vacation after this phone call for a week, for 8 days, is to sort of figure out where my different projects are, and try to figure out the way forward. I am not going to abandon you guys on that project. It's just literally when it rains, it pours in terms of these interesting outbursts. So not only do I have VY Aquarius going on, right now I'm actually working on a neutrino follow-up program based on something that occurred at 3 this morning. So.
Thank you.
You have specific questions?
I'd like to know your opinion about these systems that have been showing super hubs and standstills at the same time. There are 2 of them that were discovered just recently. What are those? Can you enlighten us?
No, I can't. I'll be honest. When it comes to the outer accretion disk, where a lot of this stuff occurs, and where a lot of what you guys tend to measure most well, that's not my particular realm of expertise. And I'm still very much learning the literature when it comes to the super humps and standstills and all those other things. So I too would love to know the answer to your question. I don't have it.
Well, but I don't think it's so surprising, because the standstills are right at the limit of like where an outburst would be happening. And so the disk is probably at that resonance state. It's just remaining there. And so that's where you would expect super humps. So I'm just surprised that they haven't been seen there before. So did you have some reason why you thought that that should not be happening? Yeah,
Is it
so I guess it's
me
not.
or you're asking Sebastian?
Yeah, I'm asking, yeah. It's
I
weird.
mean, is it just a matter of like, we haven't, I mean, Zcam behavior is kind of hard to spot, or, we need a lot of data, right?
Right,
And-
because it's what, 6 or 7 hours, right? So it's, I think it just maybe hasn't been seen because it hasn't been followed, but I think that would be I mean, supposedly the super humps are triggered when it reaches the 2 or 3 to 1 resonance, the disk reaches that size. And so in this, in the standstill ones, they should be very close, because then, I was following these IWAN things where, should it go down after a standstill or go up? And so we kind of did a spectroscopic study trying to estimate the mass accretion rate at that level. And it's right at the border of, is the disk stable or not? And so it just depends on the unique different properties of each system. So I think you should, it'd be nice to follow more of them at standstill and see if this is just a common phenomena.
I see that 2 out of the 3 have orbital periods that they are 0.10 and 0.14. So they are in the UGC period regime. Interesting. So I guess if we find 2 in 2 weeks, there will be many more hiding there.
Yeah, you'd think, but you never know, right?
Yeah.
The way statistics works. Yeah, but yeah, that was something that I've been interested in doing, or seeing if, recommending it for someone to do. I mean, we've got, lots of data, obviously, from these large surveys. And, by and large, I mean, if you or subscribe to a couple of alert channels, email, you're going to be flooded by CV outbursts and new discoveries, every day that are getting picked up. But more interestingly, that I don't know if anyone's actually doing is looking at the long-term behavior, like some of these CVs. I mean, there's just hundreds and hundreds and hundreds of them being discovered, right? And numerous outbursts. But the notification really comes out like, this is an outburst because it, got over some threshold in their detection software, which is great. But I don't think that they are looking at, because this is a harder problem, like, what's the long-term behavior of the light curve? Like, is there, is it showing Zcam behavior? What happens, if it is, what happens out of the, Zcam outburst? The AVSO had a program campaign several years ago to focus on a bunch of Zcam stars or suspected ones. And, it was hard to get enough coverage, even with that focused attention, to be able to know, this one's in standstill, especially if it's a short standstill, right? Zcam itself, if it gets stuck for 6 months, that's pretty, we're going to know about that one, right? But some of the shorter Zcam behaviors, and then, what happens after that? You have to have pretty dense coverage. And maybe I'm thinking the automated surveys are a great source of data where, you actually analyze the individual light curves of these stars and look for those Zcam type pauses in the behaviors coming out of it.
I just don't know that. I don't know that they're going. I don't know that there's enough of the objects that are close enough that we can study well. So the thing is, what most of the dwarf novae outbursts that we're tending to find now are things that are generally farther away dwarf novae outbursts. Right. And so
pick the low fruit, right? Pretty much.
So yeah, so you're right that someone needs to do it. But the problem is I'm not sure whether Assassin and those other type projects that give you the higher cadence can actually do it. And then when you get to something like LSST, it's not going to have the cadence in the same filter to do this, right? Okay. Because the way the time between observing the same point in the sky and the same filter is not the same as the type of variability that we often talk about with LSST. I also don't know for instance, I don't know how deep ZTF is going as well, or ZTF this crowd.
It goes to 20th, but that's the problem. Most of the sources after the outburst ends, they're at 20th, so you don't get any information. But a standstill would be higher level.
So I have a question. Is the standstill what we think is going on with SSA? Because its quiescent luminosity now is about a magnitude higher than it was 2 or 3 years ago.
Yeah, that's a good point. Is like I was saying, SS SIG's been observed to death, you would think, and last couple of years or last several months anyway, it's acting very oddly, right? You look at the light curve, different morphologies, and like you mentioned, Greg, the quiescent brightness is higher, and what's changed is that obviously it's probably some sort of semi-regular cyclic nature. Something's changed, at least temporarily, in the system, accretion rate or temperature or whatever. But why? Right?
Yeah, that's one of the big problems. We don't understand why some of these things just turn off sometimes and others. I mean, is it star spots? Well, that's the only explanation but we don't know if that's the right one or not. So I mean, I could see that there's just changes in the accretion, the mass transfer rate for whatever reason that elevates the overall brightness.
Right, but in quiescence, this is really so. I guess I don't know off the top of my head what the companion star of SS SIG actually is, and whether the 12th magnitude brightness that we typically measure it is actually the companion star or the accretion disk. This is stuff I should know, but like I said, my brain is dead these days.
How many thousands of CVs around now? Even the can't know much about even the common ones or the most popular.
I am adding 10 or 12 a day or more, only from Gaia. So it's really stressing for me. I have to add into VSX. So,
I have an undergrad who's putting together a catalog of he's using Assassin, Gaia, but it has some ZTF things in there, and just taking he surveys puts them all in one place. And so we're going to have this catalog coming out. We're writing a research note on it. So it's just going to be a public. Yeah, it's going to be just describing the catalog. The catalog is hosted at UW, and it's going to be open. And what we want people to do is enter, if they take any data on a source, to actually put in a comment, like I have spectra, or I have some further photometry and another filter or whatever. So it'll be a repository, and we actually reference, if you want more information about the sources, go to VSX. I mean, that's what it'll say in the research note, but we're trying, because there's so many surveys going on. It's hard to just keep track of all of them, all the ones that are coming in. So these are candidates. I mean, not all of them are proven, but we're just searching the name CV candidate and putting it into this catalog. Hopefully.
For the Gaia ones, for instance, you don't know if they are dwarf novae or supernovae because you don't have a host galaxy. You don't see it, so it might be or not. So you're not sure. Yes, you need spectra. So.
Yeah. So these are, hopefully this will be for observe. I mean, the intent that I wanted it to be just a place where observers can go, and you can order by RA, so you can see what's available in the sky and try to get some further data on some of them. And it'll have the discovery date, so you'll know whether it's soon after outburst or not, because they're pretty much all discovered at outburst. In the sky.
Sounds very useful. Kind of a clearinghouse then for data collecting.
Data aggregation is one of the hardest things that we're going to have to do in this next generation, not the next generation, in the current generation of what we're doing. It's just, it is insane how much work that we're going to have to do because everyone's doing such great work.
Yeah, well, the volume of data, right? I mean, we've gotten to the point here where surveys are pretty mature.
In my opinion, it's not the volume of data; it's the heterogeneity of the data. We've got people doing all sorts of great things all over the place, and so that just that tends to make things actually in some ways difficult. I'm not saying we should change that one iota.
No, go back to photographic plates and visual measurements only.
No, thank you.
Yeah, to your point, Greg. Yeah, looking at the light curve generator on SSSig, and it's very obvious in the default plot of the last 1,500 days. The range, to my eye, has definitely decreased a bit. The maxima are not as bright, and the minima are about 3/4 of magnitude brighter, right? Just kind of not really stuck, not a ZCAM behavior, but whether it's probably the accretion disk is just hotter, more matter, or is it the white dwarf? I guess color data would tell us a lot there, right? Or at least tell us something. We could at least eliminate, it's the secondary, which would be odd. It's probably an M dwarf, right? Like everywhere else.
No, SSSig, because it's longer period, is like a K star, I think.
Oh, okay. Oh, yeah.
Okay.
Yeah, I guess yeah.
And
Still
Sorry,
probably odd if the K star is not probably changing its brightness, so it's most likely then the disk or the white dwarf.
there's a bunch of people in here that may not be. We got really into the weeds, so to speak.
Yeah.
So
Which is all interesting, but
it's very interesting stuff. But maybe for the sake of the people who aren't as versed in this, maybe we should take a couple steps back.
What's a CV? Several steps back.
It's what you use when you're applying for a job somewhere. You attach it every time I type an email, the Outlook or is telling me, did you mean to attach something? You said CV. Like, no, I meant CV. Thank you, not my resume. But I mean, that is probably a good point, Sebastian. Like, lots of people here are regular names. I know y'all at least through email and whatever. I know you're observing. Many of you are members of CBAA, Center for Backyard Astronomy or Basement Astronomy. If you aren't,
tell us here, behave, please.
But the CV section, like all the other sections, are just a focused area on a particular technology or more often a type of object. We got the EV section and the long period variables, and the CV section obviously is focused on cataclysmic variables. Dwarf novae, being a dime a dozen, they're everywhere. Pretty much, you look, as like Sebastian was saying, a guy is just churning them out by the bucket load these days, and so are the other surveys. But novae, supernovae all fall into that cataclysmic kind of cataclysmic definition. So there's, as Greg or Paula can tell you, there's lots of, we have Cat. We have lots of, there's lots of very interesting science going on in these, even in the CVs, the typical dwarf novae. We get jets and behavior and strong magnetic fields in some cases. So there's a lot of very interesting physics, and because they're so close, a lot of them, because there's so many of them, the space density is high. The dwarf novae are a great target for being able to study a lot of this physics that even applies to supermassive black holes in the center of galaxies that you can't see because they're buried in the middle of a galaxy. So it definitely has a lot of impact.
A question, for instance, a high mass or low mass X-ray binary undergoing outburst, could they be classified as CV too?
Well, so they're not based on just history. So cataclysmic variables are, in my mind, are creating white dwarfs. Low mass X-ray binaries are creating neutron stars or creating black holes. And there's a huge zoo of cataclysmic variables, as you sort of began to hear us talk about this. And so I don't think that it's necessarily worthwhile to always put them together and say they're absolutely the same thing. But when you're talking in broad strokes, I absolutely consider them the same thing. But there are going to be differences. The neutron stars and the black holes are going to be very similar in a sense, because the neutron star, the black hole, is about between 10 and probably 30 kilometers in size. So the accretion disk can get very close to the compact object, while the white dwarf can be potentially massive, the size of the Earth. And so that's one of the things that changes their primary behavior differences, in my opinion, is that difference. There are some other differences. So, of course, between black hole X-ray binaries and neutron star X-ray binaries / cataclysmic variables, you have the difference that the neutron star.
Oops.
Great pose, Greg.
It was a very sensitive issue, it seems. We decided to censor him. I was asking that because I see that unless they are very bright, I don't think they deserve the same attention, or they get the same attention.
Which one? CVs or LMXVs or HMXVs?
He's back. You were.
Sorry, which one?
No, you were offline. Now you're back again, Greg. So
yeah. No, which ones do you think get enough attention?
No, in general. I mean, I wasn't thinking about the particular example, but I see that there are many X-ray binaries of, I don't know, 16 or 17 magnitude that they are being ignored, and there are many CVs at those magnitudes that are being observed. So I noticed that. So maybe they are not so famous.
It's not. So it's not a question that of the X-ray binaries being ignored when they go into outbursts. We really, especially the high energy community is much more focused, I think, on the X-ray binaries in some ways than the cataclysmic variables. And so I think there are differences. Basically, have to do with the number density of them. There are many more cataclysmic variables than there are X-ray binaries, and so that means in general that the X-ray binaries are farther away, and so when they go into outburst to first order, they're going to be fainter.
Yeah, many X-ray binaries don't go into outburst. That's important too. Not all go into outburst. There's
not as exciting to observe. Certainly, there was a low mass X-ray binary campaign 4 or 5 years ago.
B44 Cygni and the Assassin 18Y.
I'm sorry.
B44 Cygni and Assassin 18Y were both major AVSO campaigns.
Yes, those
binaries.
Those were the famous ones I was recalling. Yes.
Yeah. So basically, I tend to start an AVSO campaign when I know we're going to do one of these objects in detail. A typical X-ray binary that repeats itself, and there's only a few of them, only tends to go into outbursts like once a year. But in a given year, there may only be 2 or 3 black hole X-ray binary outbursts, maybe a little bit more of the neutron star X-ray binary outbursts. And so that's why you don't hear about them nearly as much. SS Sig goes into outbursts more times in total a year than all the X-ray binaries in some ways. And so that's a lot of the difference. Assassin 18EY is a little bit different. It is one of the few sources that is a recurring one. And it's gotten into multiple outbursts since it went into its first outburst. GX339-4, which is a more southern low mass X-ray binary, is the prototypical recurring black hole X-ray binary. It goes into outburst about once a year. And Aquila X1 goes into outburst about once every 9 months. H1743-322 goes into outburst about once a year. That's about it for the recurring ones. So otherwise, we basically play not Russian roulette. We're playing the lottery to try to figure out if a given source is going to go into outburst. And we don't. They're faint enough that we haven't had a lot of quiescent monitoring campaigns with the optical people, although that could potentially change.
Do we see, in CVs, there's a lot of flickering, especially in some systems, mostly from the accretion disk, of course. Do we see that same kind of thing in the visual around lower high mass X-ray binaries that would, make a visual or a optical campaign worthwhile?
So we it depends on we're talking about an outburst or not. In outburst, we've seen a lot of the same behaviors. I showed in some of my plots, we're all in the X-ray binaries this past week. They have basically variability behavior on all time scales in the optical, as far as I can tell. Like there's something interesting going on almost wherever you want to look. So they're interesting. The problem is in quiescence, they tend to be pretty darn faint. So I have to think about how many, if any of them, we can really monitor with most of your guys' equipment, as opposed to I know like on the LCO telescopes, there's a campaign to monitor them organized by Dave Russell's group in Abu Dhabi. And it's like that's with the Falks telescope. So you need a much bigger telescope in order to monitor those. And this is the whole reason why we triggered on Aquila X1 was because Dave's team actually determined that Aquila X1 was going to go into outburst ahead of when the X-rays said Aquila X1 was going into outburst. So there's potentially interesting things to do. It's just a question of, you guys, are they going to be bright enough to make it worthwhile, or is it going to be basically, months and months of non-detections, and then all of a sudden there's a detection, which is worse than at least months and months of 16th magnitude detections and then a 14th magnitude detection or something like that.
I did find Dr. Sardi at University of Saskatchewan back in 2008. He had a campaign to observe high mass X-ray binaries. They were doing simultaneous spectroscopy, and there's 8 or 10 objects there in the list that I remember actually doing some observations, and just nightly they wanted photometric behavior to put against their spectroscopy data. And there are some bright objects, but as I recall, they didn't do anything exciting in the data. So that probably explains some of the lack of interest, even for bright ones. I think you can detect orbital periods in a few of them with optical data, but.
Yes. So the other interesting thing that you can do, which will, I think, be potentially very interesting for some of you all, is we've determined that measuring the flux in H alpha for CVs versus X-ray binaries is actually very important, and maybe a way of identifying a source that's likely to contain a black hole as opposed to a white dwarf or something else. And so this is something that you don't need a spectra to do. You can actually have an H alpha filter do this. And so,
sorry, go ahead.
That's so basically you can have a photometric program where you have a narrowband H alpha filter, and you can monitor these, and they might be interesting.
What, how narrow a narrowband, and what is the physics going on there? Why does that? What does that tell us, or why does that help us differentiate the objects?
So the H alpha, it has to do with the accretion disk, and essentially, if I remember properly, it's just basically it's another proxy getting at how far down the gravitational potential well you're going. And so I think if I recall quicker, you have more H alpha emission in and this is Jorge Cesares's work, and I just am blanking on the exact amount. I think the H alpha tends to be brighter in the black hole systems compared to the cataclysmic variable systems. And so just H alpha measurements alone could be interesting. And I think, like I said, you would start with just a fairly typical H alpha filter. Then there are ways you could potentially, once you find the sources, then on professional grade telescopes, you'd go in for the actual H alpha spectra. So you could do things like measure how wide the H alpha emission was, which tells you a proxy for how big the disk is.
If the resolution of like the SA200, the slitless diffraction filter, would be high enough. I mean, basically, you get a spectrum from it, full width usually, depending on or usually use the first order, and you'd be able to use a sort of like having an HF alpha filter, right? Just measure the brightness, the flux around the H alpha line in your spectrum compared to the continuum or nearby.
Yeah, it's possible. I'm trying to see if I can get a link for so in the chat window, I will put a link to a potentially interesting paper. You all can take a look at and evaluate that. Okay, and
Okay. Yeah, it have to be a fairly bright object for, well, let's say a spectroscope or the H alpha filter, depending on how narrow band you need or you'd aim for. But that'd be something interesting. I'll take a look at that article and anyone else who wants. I did want to take, like you said, Greg, we've been talking away at specific things and specific objects and haven't really given everybody else a chance to pipe in. I'd hope you'd raise your hand and, wave your arms, but we have kind of been carrying on. Other questions? Let's see, we've got folks coming and going here. And like I said, I know many of you, but if somebody's got some questions on cataclysmic variables or want to mention something or however, floor is open.
Yeah, remember this is an informal meeting, so you can speak, show yourself, don't be shy. We were talking about how often stars go into outburst. I was thinking about why we are looking at so many recurrent novae in M31 these days. Is there a reason why there are so many recurrent nova there, or it's just random? I don't know. And especially that they go into outbursts very frequently, every year or 2 years or 10 years. They are not like the recurrent novae in our own galaxy, it seems. It's just random.
It may be a selection effect. It's very easy to monitor M31 compared how it is to monitor the galaxy. So that's one reason why. It also may be an extinction effect, because perhaps we're not seeing nova throughout the entire disk, but we can see the nova much more easily in Andromeda, where we're not looking through a disk. So that's my suspicion is what's going on, but I'm not. That's my pulling stuff from the nether regions, not a detailed thought out reason.
It sounds sensible. Yes, it's common sense. Yes. Mm-hmm.
Yeah. Speaking, recurrent nova. I mean, we have. I can't remember N31 or M31 N2008-2 or whatever it is. I'm sure Sebastian can correct me on that.
The names are very difficult to memorize now.
the recurrent nova. We thought USCO in our galaxy was pretty special. Every 10 years, this thing goes into novae outburst. It was the most rapid repeater, and they go off and find this recurrent nova in the M31 that basically every year, like clockwork, it goes into outbursts. So obviously there's some massive amount of mass transfer going on with a very large white dwarf accumulating matter very rapidly. So they can have this thermonuclear explosion on its surface, every year. And what's amazing is that, clearly the white dwarf never cools off, right? This thing is popping off once a year. So, presumably the white dwarf is actually, getting gradually hotter and maybe more massive, depending on, what the physics is there. We're still not sure. Even objects and recurrent nova in our galaxy, but
So are they supposed to be the most massive ones, the supernovae candidates then?
Yeah, on the recurrence, I think most of those white dwarfs in those systems tend to be fairly close to the Chandrasekhar limit, just because they need to be bigger and more massive to be able to accumulate matter more quickly through the accretion disk. Otherwise, matter, tends to, the accretion rate's not as high, so it just piles up in the accretion disk and then occasionally falls down onto the surface or drains to the surface. But and then recurrent novae, I think the white dwarfs are very large and probably getting more massive over time as the matter accumulates. Doesn't all get blown off in each eruption. So maybe that we'll see that recurrent nova in M31. It might be our next nearby supernova. If none of us live to see one in our galaxy, the way it's going, 500 years and counting. It's rather sad.
What's the magnitude of that?
I'm sorry?
What's the magnitude of that nova in M31?
I think it gets to about 17. I imaged it the last outburst, previous one. So it's in a fairly sparse field in M31. It's not right near the core, so it's pretty easy to pick up with a CCD and a larger telescope. Don't necessarily get great photometry, 17.5 or whatever, but yeah, you certainly can detect it, and it's quite a neat object. So when it goes into outburst, you can actually detect this in another galaxy going off. There's lots of novae, classical novae that get detected in M31 also, and the other, obviously all the galaxies, but they're a little bit fainter. Typically, they don't have quite as bright an outburst, so 18 or so, and so they're a little harder to pick up. But
Not the sort of thing you'll get with a 19-inch telescope. Then.
yeah, but yeah. And speaking of recurrent novae, that's obviously falls into the cataclysmic variable category. White dwarf accreting matter and going into outburst. There's 10 or so in our galaxy known, and so that's something interesting to observe. Also, Dr. Schaefer at LSU has been studying those and ran that USCO program for the last several years through the AAVSO. And sadly, we missed USCO's outburst. It was apparently went into outburst while it was behind the sun, and it's a very fast nova. So, like in 10 days, it's outburst and fades back to almost to quiescence. So you really have to keep a close eye on it. And this last outburst last winter, I think it was when it was behind the sun. But there are others that are coming due based on historical trends. We've seen 2, 3, or 4 outbursts in some of these other slower recurrent objects. So they're always a good one to keep an eye on. You can get the list of recurrent novae out of the VSX database. And about a year ago, I think Dr. Schaefer had posted to the AVSO a list of the objects with his predictions on when they'd go into outburst, plus or minus 2 years or whatever, right? But still...
yeah, I might check in VSX and I see that there are 14 or 15 in the galaxy right now.
There you go.
28 in total, but we have some of them on M31 and in the Magellanic Clouds. So this leaves with 14 or 15. Some are not confirmed, so more or less.
Yeah. That's I have a few of those in my program. I try to get a look at them in measurement every night. Of course, I'm not processing my data as promptly as I should be. So most likely what will happen is that there will be one, it will go into outburst, and I will notice it, when I go look at my images 3 days later, and sadly, after someone else's, started observing it. But I need to maybe tighten that up a little bit. Doesn't do to be observing it and then not not detect the outburst. Well, I think we got folks got questions. Other things they want to discuss. I did want to mention the Center for Backyard Astronomy, cbastro.org. Group of amateurs and a few professionals who study mostly intermediate polars, which are high magnetic field cataclysmic variables, as well as oddball types of CVs. And published a lot of papers and collected lots of data. And so you get a lot of great guidance on what's going on in the systems that they're interested in, and what kind of data to accumulate. That's always been my problem, is that even before Guy and all these other surveys came along, like, oh, there's a new cataclysmic variable, it's an outburst, you get 10 of those a day now. And like, well, okay, it's just probably another UGSS, an SS Cygni type star that's in outbursts, so probably not very exciting, right? VY Query, I probably would not have paid much attention to. Like, oh, even super outbursts aren't that uncommon, but obviously there's a lot more interest in that. So it was good to have that feedback right away.
Greg Babbage is asking if you could recommend books that are at an intermediate undergrad level.
So
I see.
The classic book that I always suggest people look at, and it may not be the simplest one right now, I think about it for this level, is oh god, Warner's book on called Cataclysmic Variables, if I recall it properly. Warner is, in some ways the one of the people that helped birth the field of study of Brian Warner is one of the people who helped birth the study of this field of CVs. And so he's absolutely an expert at that. I don't know. It's been a while since I looked at it for me to remember if it's at a intermediate undergrad level or at a more advanced undergraduate level. There is another book that, let me get the exact title. So Phil Charles and gosh. I'm completely blanking on. I think it's Exploring the X-Ray Universe. Yeah, I think the one Exploring the X-Ray Universe by Seward and Charles. So I'll put these in the chat.
Yeah, I enjoyed Warner's Cataclysmic Variable Stars. It's decent amount of physics and math, which it's been a lot of years since my undergrad physics days. So skimmed through some of that, but a lot of interesting information, and helped grasp a lot of what was going on at basic level in CVs. So what other questions? I think we're getting to about the end time that they recommended, not that we have to stop. This thing's open as long as we want it to be. Did on the CV page on the AVSO site, we have several links, one for the CV Astro page, and also to the website that Patrick Schmier maintains, where he is diligently collecting data and about outbursts and publications also to some extent. So there's lots of good data there about current outbursts and some ideas on what's important to observe, right? And BSNet in Japan, they do a lot of issue Ursa Majori stars, super outburst stars, and study a lot more of those, and oddballs, and so they collect a lot of data also, and have some unofficial campaigns or whatever, or calls for observations anyway, which can kind of you read the. But
no, I was saying that I can tell you that it's much easier to update information on cataclysmic variables than any other type of variables, because everyone is talking about them all the time, everywhere. So you have information coming all the time. So yes, it's different than any other type of variables. You have to go and look the information yourself, and it's not so easy.
Yeah, seems to be much more excitement, right? A lot more research being done. I mean, eclipsing binaries, very interesting, nice light curves, it's great. And some of them change period, over the course of years. So like, oh, that's kind of neat. Yeah. 40 years of data, I can see something. And the same thing with, short period pulsators, which, some of those, a lot of, different frequencies, are Lyraes and especially in like the Delta Scutis. And so you can get a lot of data, and do a lot of neat analysis there in short order. I used to spend a lot of time with Delta Scutis actually. But CVs, they're cataclysmic, all kinds of crazy stuff's happening there.
Yeah. Well, but don't forget to mention the YSOs that Mike is here. So
yeah. That, I do have.
He makes a very good job publicizing every time a YSO just does something interesting. Yeah.
yeah. I have quite a few YSOs in my program too.
And they show outwards too. So you have the XORs, the UXORs, the FUORs. So they're very interesting too. Yeah.
Yeah, well, that's the problem, right? There's just so much. I have 2 telescopes with photometers, and like I could have 10. I've got this giant list of targets, and like, I can't do these stars tonight.
I'm here now.
Hi, Philip.
Hi, Philip. How are you?
Oh, Sebastian.
How are things going on the high energy network session?
They write about my observations of gamma ray bursts and BL blazar. And they wrote, they say that it's very interesting, and some questions for me, they say.
So you have observations of gamma ray burst? Interesting.
Yes.
People say that. Yes.
Yes, it was difficult, but on December 22 in last year, I observed it. It was short for me with remote telescopes. But last observations were unsuccessful. But this was very bright afterglow, about 18 magnitudes. And
yes, they evolve very rapidly. So if you don't observe rapidly, they go away. They fade very quickly. Yeah. Great, congratulations.
Thanks.
Never had a luck to catch a GRB. There for a while, I think the previous iteration of the high energy network, I used to put out alerts and tried a few times, had no luck, but that seems to be the story, right? Even the rapid response automated telescopes, in a lot of cases, we still don't see any optical signal. If you're looking in the right place at the right time, it's still not, there's nothing to see. So you have to both be quick and to be a little lucky.
Yeah.
All right. Like I said, I didn't really have much. Took some notes. We're trying, I mentioned earlier, we still got for a number of people. Trying to get together some programs. I think one of the big challenges is what to look at, right? What's scientifically valuable. So we're doing a decent job, I think, especially Patrick's work has helped, and the alert notices with the campaigns and alert notices. There's professionals are giving us some guidance there. That's always valuable. Hopefully, we can have some more homegrown with some guidance from some of the professionals on lists of targets, or at least some ideas of what kinds of targets would be useful. A discussion we had earlier about the low mass, high mass X-ray binaries. Sounds like probably not a lot of value there unless there's a focused program going on, but with a professional. But there are lots of other classes of objects that we can probably get value, like the searching for orbital periods in post-novae systems. In fact, one of the people in the CV section, whose name escapes me at the moment, published a paper, observations he made. It wasn't V339 Del, another recent nova, where he was able to actually from urban Washington, D.C., he was able to, with his telescope, to measure the orbital period of this nova that was like, faded down, heading down to quiescence. So it was, I think, 17th magnitude. And I live in suburban Orlando, kind of, there's a lot of still open space around me, and Milky Way is visible once in a while. Like, 17th magnitude, that's pretty good. I don't get great photometry at 17th magnitude, so it was pretty impressive data that he collected.
I think Mike is talking, but we can hear him. Mike, we can't hear you. Something is not right. You're not muted, so I don't know what's happening.
Okay, is that any better? Can you hear me now?
Yes,
Oh,
yes.
right. The problem apparently was Mike's mic was too far away.
So you were speaking before?
No, just a question on recurrent novae. Do you think it would be worth publishing a list of which ones are kind of overdue?
Yeah, I'll that's a good point. I'll dig up, because, like I said, Dr. Schaefer had made some predictions a couple of years ago. I can dig that up. I think it's buried in one of the forums somewhere, but that would be a good thing for right on the CV section page. And I don't think any of them were close. I think like 2024 maybe was the next one that he was predicting. Again, plus or minus a couple of years. So, but when we get close, it'd be definitely a good thing to put out more, put the call out for more dense coverage. And pretty much, if you have a big enough telescope and a CCD, you can point at the Andromeda Galaxy anytime and try to catch that rapidly recurring.
Most in our galaxy have very long recurrence periods. So, and from time to time, we discover a new one that was actually a known nova from the past, and it turned out to be recurrent. Actually, all are recurrent in some scale.
Yeah,
right. Just a very long time scale.
Yeah. As time goes on, obviously, we go back. Harvard Sky Survey, and obviously fairly dense, just visual coverage of just people being out. So if it was a bright nova, we would have picked it up, obviously.
Well,
but
GK Persei, I haven't. So that's usually fairly reliable to do something.
GK Persei is a very interesting system there. It's got all kinds of things going on.
Really?
Yeah, just from nova, and then occasional like mini dwarf nova outbursts, right? Yeah. And lots of flickering even when into quiescence. So it's again probably because it's recurrent in a short time scale, there's a pretty high mass transfer rate and probably a massive white dwarf component. So you expect to see more activity there in a system like that. Like USCO in quiescence is so faint that I can't remember one of the VSO observers was actually measuring eclipses, because it's actually an eclipsing system, but in quiescence it's like 18th magnitude. But his equipment was sufficient, he carefully could collect enough photons even then so he could measure the eclipse.
What would be the main difference regarding why one novae becomes a dwarf novae, another novae becomes a recurrent nova? So what would be the difference there?
I think has a lot to do with just life cycle. If like you look at BK Lynxus was thought to have been a nova several thousand years ago. It's a dwarf nova now. Occasionally, we're starting to become a dwarf nova, and it it seems like the CVs tend to go through a cycle of, they get more massive, the orbital periods are changing because of the mass transfer going on. And so you'll get these systems that flip between, maybe doing very little, they're in a more or less quiescent state all of the time, which we can't see them, or they're, there's no way to detect them. And then orbital period shortens enough that, secondary is close enough that the accretion disk forms and we start seeing cataclysmic variable outbursts. Mass is accumulating on the surface of the white dwarf all the time during dwarf novae outbursts because it doesn't burn on the surface. And mass, gets hotter and hotter, the layer gets thicker and thicker, and you finally get a nova outburst. And then after the nova goes off, the white dwarf is so hot and the accretion disk maybe can't form. And so you don't see any CV activity at all. It maybe looks nova-like for decades, hundreds of years maybe. And then as it cools and the orbital period, settles down again, begins to again contract some more. Then, disk forms again and you start seeing CV activity, and then you repeat again and again, which is why recurrent novae mass transfer rate is probably so high and the white dwarf is so massive, it's the accretion disk doesn't really go into outburst, and so it's just quiescent until finally the layer builds up enough to explode. So it's probably an extreme example of novae where it just skips the CV phase entirely. But again, there's so much variation, right? Even if you don't even talk about the magnetic, intermediate polars and DQ Hercules type stars, which have got this massive magnetic field, which changes the whole accretion disk picture, or you get an accretion disk. Just you have this range of white dwarf masses and secondary star masses. Some of them are giants, and others are little tiny red dwarfs, and they're in really tiny little orbits. So your mass transfer rates are different. Accretion disk size is limited perhaps in closed systems. So you get all kinds of these weird, or you get this whole wide range of phenomena. That's why it's been so hard to figure out what's going on.
Thanks.
Yeah, I talk a lot, don't I?
There are so many interesting things among CVs. We have the luminous red novae now, the red new category. They are very interesting objects too.
Yes. Yeah, and not clear exactly what's going on there, I don't think, right? It's bright, or suddenly gets this massive outburst, and then it just kind of stays there. The red V838 Mon.
Yeah.
Yeah.
Couple of in Scorpius and Sagittarius too, and they are supposed to be mergers. That's the main explanation. The main sequence merging with another star. So they're kind of different. I don't know if they should be called novae actually, but well.
They're people. It's one of the terms they use for them, but it's not the only term. And I think one of the reasons why people didn't like the novae aspect of it. But in the end, I don't think we need to worry about whether it's a novae or not. We should basically decide: do you want to observe it or not?
Yeah, and they get lost among the dust that is produced, and so they can't observe them anymore. They become too red and disappear almost in visual wavelengths. So they are very interesting. Yes.
Yeah. Talking about red, V838 Mon is what? B minus V of 3 or 4 or something ridiculous like that. I gave up trying to imaging it in B because it just takes too long. Can't collect enough photons in the B wavelength.
This one was.
Do we regard stars like BF Sig as cataclysmic? Because the kind of setup is sort of the same, isn't it? You've got your sort of main sequence star, and you've got your white dwarf. BF Sig, CI Sig, Z Andromedae. Those I think they used to call them Nova Light.
Yeah, they're still part of CVs. I'm pretty sure. Or I thought. Wait a minute. I have to remember. I know I published on them. I think there's still a subcategory of CVs,
Right.
as far as I can remember. So
Yeah, because
it just basically, if it's accreting against a white dwarf, I think most of us consider it a CV, and then you can start getting the zoo after that.
Yeah, yeah. The sort of geometry is different somehow, isn't it? Obviously.
And when I say
Yeah.
accreting, I should say if it's got an accretion disk and it's got a white dwarf, it's a CV. I'm guessing because the polars are CVs, right?
Yes.
yeah, even though they don't have an accretion disk, right?
Yes, they are
Well-
But I mean, it's kind of just at the extreme end of the spectrum there, I guess, through intermediate polars to DQ Herc stars. But yeah, I guess symbiotics like Z Andromedy, right? It's the same pattern, right? It's just the white dwarf, and in this case, usually a red dwarf or a red giant or a K, big star, and just in a bigger orbit, but it's still accreting matter onto the white dwarf. And I mean, we see outbursts in these kinds of systems still occasionally. Not
Yes,
clear
that's-
exactly why some do and some don't.
When I read the definitions, they say that, I don't know, for instance, VY Sculptori stars, they shouldn't show outburst. And from time to time, I find some examples showing an outburst, things like that. It's happening continuously right now. DQ stars, DQ Hercules stars, VY Sculptori stars, and then there is an outburst there. So, I don't know. So it's possible then.
Like you say, it's a real zoo, isn't it?
Yeah,
Wow.
I mean, for that matter, we included, supernovae in the CV category, but the type 2s, there's no white dwarf there, so it's again, there's no accretion, there's no, but it's clearly cataclysmic though, right? It's the biggest outburst destroys the star usually or often.
Yes, actually, I don't know if they should be called variable at all, because they just vary once.
Yeah, one-time variable, right?
Yeah.
Although maybe it's maybe they were a luminous blue variable before they went into supernova. I don't know, probably.
All
But,
transient sources are variable. Not all variables are transients.
Yeah.
I'm going to have to shoot off now. Thanks, everyone.
Okay. Bye, Steve.
Bye.
Nice seeing you.
Thank you.
Well, I think we can be finishing this. It's been very interesting, really.
Yeah, it's been good.
It was
I
nice.
appreciate y'all joining in. Hope we didn't bore you too much talking about VY query and the black holes and neutron stars and whatnot. But
We covered all aspects, and you asked if there were questions, so we're okay. Yes. Great. Well, I hope we can meet in person next year.
I hope so.
You're all-
I'm an introvert, but I'm beginning to get a little tired of this.
Yeah.
Never leave
Some
the
people
house.
feel more comfortable this way, but I don't like it.
No, it's not the same.
I work all the time in front of my screen, so doing it again and again and again is becoming really stressing for me. So,
Yeah.
okay. Well, guys, it's been a pleasure. Thanks for joining, and see you soon.
Bye.
Bye-bye.
Goodbye.
Thanks, John. Bye,
Thank you.
Philip. Bye.
Goodbye, Sebastian.
Bye.